Read the question carefully. So we got a rock that is thrown upward on the planet Mars with a velocity of 10 meters per second. Height in meters t seconds later is given by this function. So we got height function y. Y is a function of t, by the way. Y is given by t. Find the average velocity over the given time intervals. So the average velocity over 1, 2, 3, 4, 5 different time intervals. And these time intervals start at 1 in each case. And the second time is now 2, 1.5, 1.1, 1.01, 1.001. So these second numbers are in fact going very, very close to 1, the first number. Okay? And from this trend, we should be able to estimate the instantaneous velocity. So here is average velocity, over the second time, in fact, going towards 1. From there, we can estimate the instantaneous velocity. So the average velocity means change in height divided by change in time. Yes. Velocity is always displacement over time. In this case, the height in these two different times divided by the time. So the formula in each case, 1, 2, 3, 4, will be height y at the second time, so 2, 1.5, 1.1, etc., minus y at the first time. In fact, here we got 1, 1, 1, 1. So t1, which is 1, divided by t2 minus t1. Okay, so that's the average velocity. Okay, this is height. So the average velocity is given by this formula, where t1, t2 is the given time interval, and this y is height. So let me set up for 5 different cases, because we got in part 1 now, this one is like t1, t2. Repeat, t1, t2, t1, t2. And let me put that, okay, and I'll come back. Let me pause the video. So part 1, on this interval 1 to 2, using this average velocity formula, we got y, the height at 2 minus height at 1 divided by 2 minus 1. Part 2, same thing, 1.5. Okay, part 3, 1.1. Part 4, 1.01. Part 5, okay, I just set up. Now we need to evaluate the height at 2. That means plug in t equals 2 here. So that's the y2. So we'll have, using calculator, 12.56 minus y1 means plug in 1 there. So we get 8.14. All over 2 minus 1 is 1. Look, this y1 are same in each case. So 8.14 will be same. And again, use calculator, we get these values. So let me write those values, pretty much using a calculator now. So when we plug in these values, then we get this one. These are approximate, okay? We can write equal to, but we are just approximating. For this one, just the height at 1.1 minus height at 1, and then divide by 0.1. And average velocity, so units are meters per second in each case, okay? Better, these are approximations. That's all A. In part B, so we are asked to estimate the instantaneous velocity. So in this case, the second time, these two, 1.5, 1.1, they are coming towards 1.001. Okay, that is very, very close to 1. That means these average velocities, if you look at closely, they are going towards what? 6.26, 6.278. So it will be approximately 6.2, it's around 278, maybe 28, okay, meters per second. final